Shall I start, sir? Hello, good morning, students. Welcome back to the TSRJC chemistry class. We have already started stoichiometry. This is the part 4. Okay. Yesterday we have seen about the steps to find out the empirical formula from the given data. Okay. We understood that what is an empirical formula and molecular formula. Empirical formula gives an idea about the ratio of the elements. Okay. And whereas molecular formula, it gives the exact number of elements present in a compound. Okay. In sense, we can say that molecular formula is the true formula. Okay. And we have discussed a few problems about how to obtain the empirical formula as well as molecular formula depending upon the data given. Okay, this is all we have discussed yesterday. Hope you have understood these problems, right? So let me quickly revise it. Whenever the data is given, what we are supposed to do? We have to convert the percentage composition into the grams. Okay, that is the first step. Then we have to convert that weight into the moles. How can we do that? We can do it by dividing the weight by the atomic weight of the element. For example, you see in this problem, you see the weight of potassium is 26.57. So we are converting it into the moles. So what we have to do? We have to divide this 26.57 by 39. So we get the number of moles of potassium. So similarly, we are doing the same thing over here for chromium, okay, as well for oxygen. So among these three elements, which is the smallest number? 0.68. So what we have to do? Whatever the number of moles we get, that we have to divide it with the smallest number. Okay, you see here 0.68 by 0.68. We are getting it as 1. Again, here also we get 1. 2.38 divided by 0.68. We are getting it as 3.5. So here one point what you have to notice is, now you should not round off this 3.5 to 4, because 3.5 is a large number. We cannot round it off to 4. Okay. So what we are doing is, we are multiplying these numbers, that is 1, 3, 3.5 with the smallest number, so that we are getting a whole number. Okay. Because it is having 3.5, if I multiply it with 2, this becomes a whole number, that is 7. Same thing, 1 into 2, it is 2. 1 into 2, it is 2. So in this compound, the empirical formula, okay, this compound contains 2 atoms of potassium, 2 atoms of chromium, and 7 atoms of oxygen. So what is the empirical formula? K2Cr2O7. Okay. Hope you have understood. Please practice this. Yeah. Today, we are going to learn further more problems, the stoichiometric calculations. Okay. So, the problems in stoichiometry, they are divided into different types, or they are classified as different types. So they are classified as mole-mole problems. That means the mole of the reactant is given. Suppose in a reaction, 2 reactants are reacting and giving you the product, right? So they can ask you to find the relation between the reactant, first reactant and the product, or second reactant and the product, or 2 reactants. How much the 2 reactants have to combine to give the product. So based on that, they will be asking you. They can ask you either the mole-mole relationship, or mole mass relationship, that is weight, mole weight relationship, or else mass relationship. It could be mass volume, or else volume. Okay. And yesterday we have seen the important relation. What did we see? 1 mole of any substance will be having the weight equal to its molecular weight. Yes or no? Suppose, I'll tell one example. If you take water, what is the molecular weight of water? 18 grams. Okay, so whenever I take 18 grams of water, that means it is 1 mole. Okay, suppose if it is carbon dioxide, what is the molecular weight? 44 grams. Suppose if I am taking 44 grams of carbon dioxide, I can take 10 grams, 20 grams, how much ever amount we want, we can take. But if I take 44 grams, because the weight is equal to the molecular weight, then we say that it is 1 mole. Okay, and we have also discussed that 1 mole of a substance will be having Avogadro number of particles. What is Avogadro's number? It is 6.022 into 10 to the power of 23. Okay, this value is constant. You have to remember this value. Okay, so 1 mole of any substance will be having Avogadro number of particles. Particles means what? It could be the molecules, it could be the atoms, or it could be the ions. Okay, and another thing what we have learned yesterday, 1 mole of a gas would be occupying 22.4 liters of volume. Okay, so let us consider the case of carbon dioxide only. So 1 mole means its weight is 44 grams. It will be having 6.022 into 10 to the power of 23 molecules. Okay, and what would be the volume? It occupies about 22.4 liters of volume at STP, that is standard temperature and pressure. So this we have learned yesterday. So now we will be seeing few problems based on these concepts. Yeah. So please make a note down of it, right? Okay. See, what is the problem given? Let us see. What volume of hydrogen at STP is required to reduce 0.795 grams of copper oxide to give copper and water? Okay. So what is the reaction? H2 and CuO, that is copper oxide, they are reacting and forming copper and water. So whenever you are doing the problems in stoichiometry, the first and the most important step is that we have to write the balanced equation. Okay, already you have learned in your 10th class how to balance a chemical equation. So the first and most important step is we have to write the balanced equation. Okay, now you see what is the balanced equation? The equation which contains equal number of same number of atoms. For example, you see on this reactant side, this left side is called as a reactant side and this right side is called as the product side. Okay, on the reactant side, how many coppers are there? 1 copper. On the product side, only 1 copper. On the reactant side, 1 oxygen. On the product side, 1 oxygen. On the reactant side, you see how many hydrogens are there? 2 hydrogens. Here, 2 hydrogens. Okay, so this is a balanced equation. Okay, so if it is not a balanced equation, you have to balance. If it is a balance, no problem. Next, you have to go to that. What is given? Let us see. So from this stoichiometry, what do you understand? 1 mole of hydrogen. Nothing is written in front of hydrogen. That means its coefficient is 1. So 1 mole of hydrogen reacts with 1 mole of copper oxide to form 1 mole of copper and 1 mole of water. Okay, this you can infer. You have to get this information by seeing the balanced equation. Okay, so now what is being asked in the question? Volume of hydrogen is asked and weight is given. So the relation is between volume and weight. Okay, so now see. So from the stoichiometry of the reaction, 1 mole of copper oxide, that is its weight is 79.5 grams. 1 mole of copper oxide, its weight is 79.5 grams. It needs 22.4 liters of hydrogen. Okay, this is from the stoichiometry of the reaction. Stoichiometry in the sense from the balanced equation. Okay, so we are writing the simple version of here. So, simple version of it. You see here, 79.5 grams of copper oxide needs 22.4 liters of hydrogen. Okay, 79.5 grams of copper oxide needs 22.4 liters of hydrogen. So what is the amount given to us? 0.795. Okay, this amount needs how much of hydrogen? Okay, just to cross multiply this. While you are writing this, see, the problems are very simple if you understand the concept. Same quantities you should write below. Here I have written about copper oxide, below also I have written copper oxide. Here this side I have written about hydrogen, and this side we have to write about hydrogen only. So this is what is asked. This is the unknown quantity. Okay, whichever quantity is not known, let us assume it as X. Now once we write this correctly, then simply you have to go for cross multiplication. So 0.795 into 22.4 is equal to 79.5 into X. This is what. Okay. So this upon further calculation gives us as 224 ml or 0.224 liters. Okay, we are converting that liters into ml. We know that 1 liter is equal to 100 ml. So 0.224 into 1000 gives us, okay, 224 ml. So final conclusion is that 0.795 grams of copper oxide requires 224 ml of hydrogen at STP. Okay, hope you have understood this. So please read the question, don't panic by seeing the problems. Read the question, write down the correct balanced equation and see what quantities are given, what is asked. That you have to analyze. Once you analyze correctly, remaining part is very easy. Next, let us see another problem. See. What is given? Calculate the volume of oxygen at STP required to completely burn 100 ml of acetylene. So here in the question they did not give you what is acetylene. Acetylene is what? C2H2, that is acetylene. Okay, or ethine. Ethine is acetylene. This you have already learned in your 10th. C2H2 is ethylene. Acetylene, sorry, acetylene or ethine. Okay, C2H2, it reacts with oxygen and forms carbon dioxide and water. Okay, already you have learned that combustion of hydrocarbons will give us carbon dioxide and water. So how many ever carbons are there, those many number of carbon dioxide molecules you should write for balancing the combustion of hydrocarbon reactions. Okay, C2H2 is a hydrocarbon because it is made up of carbon and hydrogen only. Okay, so this is upon combustion. What is combustion? Burning in the presence of oxygen. That is called as combustion. So combustion of hydrocarbons will give us carbon dioxide and water. That you have to keep it in your mind. Okay. So see the balanced equation. 2 carbons are there on the reactant side. So we have to write 2 carbon dioxides. And 2 hydrogens are there. Those many, how many ever hydrogens are there, we have to write it as water. So H2 is there. So we have to simply write it as H2O. So it becomes the water. Now we have to balance the oxygen. So totally how many oxygens are there on the product side? 4. 2 into 2, 4 plus 1, 5. Okay. So Instead of writing 5O2, if I write 5O2, it would be 5 into 2, it becomes 10. So I'm writing it as 5 by 2 O2. Okay, 5 by 2 O2. O2 no, 2 atoms. So the 2 gets cancelled. So 5 oxygens we get. So this is the balanced equation. Okay, so now you see, as per the stoichiometry of the reaction, 1 mole or 22.4 liters of acetylene. Okay, you see here 1 mole of acetylene. Since it is a gas, what would be the volume of it? 22.4 liters. Okay, so 22.4 liters of acetylene reacts with 5 by 2 moles. So what would be the volume of this 5 by 2 moles? We know that 1 mole of gas will occupy 22.4 liters. So 5 by 2 into 22.4 liters of oxygen is required. Okay, this we have to understand from the stoichiometry. Now, what is given? We are given with 100 ml of acetylene and we are supposed to find out the volume of oxygen. So the relation between acetylene and oxygen we have to see now. Okay, so 22.4 liters, this can also be written as 22,400 ml. Okay, 22,400 ml of acetylene needs 5 by 2 into 22.4 into 1000 ml of oxygen. Okay, and we are given with 100 ml of acetylene. So how much of oxygen is required we have to find out. I don't know, simply cross multiply it. So upon cross multiplication and simplification, we get it as 250 ml. Okay, so 100 ml of acetylene needs 250 ml of oxygen to burn completely. Okay, what is the use of acetylene? Acetylene is used for welding purposes. Okay, gas welding, they say no. What is the gas used? Acetylene is used. Mixture of acetylene and oxygen is used. Okay, if proper amount of oxygen is not supplied, what happens? Acetylene would not combust properly. Combustion reactions, they give large amount of energy. So if proper oxygen is not given, acetylene forms carbon monoxide instead of forming carbon dioxide. So the reaction would go waste, right? So for that reason, we are studying stoichiometry. So stoichiometry helps us to know how much of reactant should be used, how much product we will get. Depending on these calculations, we will come to know. Okay, so that we can avoid wastage. Okay, by learning stoichiometry, we can get the efficiency of the reaction. Okay, if it is giving large amount of energy, we can easily weld. I just now said no. Acetylene is used for welding purpose. Okay, welding is nothing but we are melting the metals and joining the metals. That is what is welding. So it requires very high amount of energy. Okay, in order for the proper combustion of acetylene, we need particular amount of oxygen. So how are we coming to know that? By using stoichiometric calculations. Okay. Yeah. Next problem. Next relationship. What it is? Let us see here. Problem based on volume, number of molecules. Okay. So see the problem. Calculate the number of molecules present in 1.12 into 10 to the power of minus 7 cc. What is cc? Cubic centimeter of a gas at STP. Cc is also called as ml. Okay. So we know that 22,400 ml or 22.4 liters of a gas at STP has 6.022 into 10 to the power of 3 molecules, Avogadro number of molecules. This relation we know that. Okay. Now what is given? Some volume of the gas is given and we are supposed to find out the number of molecules. Okay, so see here, it is simple. 22,400 ml has Avogadro number of molecules. So 1.12 into 10 to the power of minus 7 ml has how much? Okay, go for cross multiplication. You will get the answer. Okay, solve this. I have just stopped over here so that you can do the further calculation. Yeah. Let us see another problem. So what is given in this problem? Let us see. Problem based on weight, number of molecules relationship. Okay. So now we have to relate the weight and number of molecules. So what do we know? Molecular weight of a substance will be having Avogadro number of molecules. So some weight we will be given in the problem. That weight will be having how many molecules that we have to find out. So let us see here. Let us see the question. How many molecules of glucose are present in 5.23 grams of glucose? Okay. So first, what do we need to know here? No need of a equation. It is a very simple question. How many molecules of glucose are present in 5.23 grams of glucose? Okay. We know that 1 mole of glucose means its weight is 180 grams because 180 grams is the molecular weight of glucose. Okay. And 180 grams of glucose will be having how many particles? Avogadro number of particles. That is 6.022 into 10 to the power of 23. Okay. So you see here, again, 180 grams has these many particles, 5.3 has how much? Go for cross multiplication. So unknown quantity is taken as x. 180 into x is equal to 5.32 into 6.022 into 10 to the power of 23. So this upon solving, you'll get the answer. That is 1.75 into 10 power 22 molecules. Okay. Hope you have understood it. So please, today's your homework is you have to solve the problems given at the end of the textbook. Number of problems are given at the end of the textbook. You all have to solve it. Okay. And please do not pile up. And I'll do the problems later. You don't be in that state. You have to simultaneously do. Then only you will be able to cover up your portion. Yeah. Next, another problem. Let us see. Problem based on weight mole relationship. Okay. So here we are seeing the weight and the number of moles. Now you see what is given. How many number of moles of glucose are present in 540 grams of glucose? Okay. Here the weight is given and we are supposed to find out the number of moles, number of moles, sorry. Okay. We know that 1 mole of glucose, its weight is 180 grams. Okay. And we are given with 540 grams. So we have to find out the number of moles. So we know that 1 mole has 180 grams. So 540 grams has how much? How many moles? Okay. Same cross multiplication only. Okay. So 1 mole into 540 grams is equal to x into 180 grams. So this upon further solving gives us 3 moles. Okay. You please learn the concept. We can frame so many formulas, but if it will be difficult for you to learn the formulas, you will get confused which formula to use at what time. So instead, learn the concept. The concept is nothing but 1 mole has molecular weight. Okay. How many moles are present in the given weight? So this is only the simplest thing. Learn the concept. Yeah. Let us see another problem. calculate the weight of 0.1 mole of sodium carbonate. So what is given here? Some moles are given and we are supposed to find out the weight of it. Okay. So first thing we need to know the formula of the compound. If you know the formula, we can calculate its molecular weight. Okay. So what is sodium carbonate? Na2CO3. Okay. This also you have learned in your 10th class. Acids, bases and salts, sodium carbonate. What is the use of sodium carbonate? Sodium carbonate is used as washing soda. Okay. So the molecular weight of Na2CO3 is 106 grams. So that means what? If the molecular weight is 106 grams, means it is 1 mole. Okay. And we are in the problem given as 0.1 mole. So we have to find out the weight. You see here, 106 grams means 1 mole. 0.1 mole has how much weight? Okay. So same thing here. Again, we have to go for the cross multiplication. So you'll get it as 10.6 grams. Yeah. Here the simple version only, again it is given. Relation between mass, mole and number of molecules. Okay. 1 mole of a substance has mass equal to its molar mass. That already we have discussed. 1 mole means its weight is equal to the molecular mass. And what is given? 1 mole of a substance has Avogadro number of particles. Okay, what is the Avogadro number? 6.022 into 10 to the power of 23 particles. We are saying it as particles because it could be molecule, atom or ion. So better say it as particles. Next, 1 mole of a gas occupies 22.4 liters of volume. Okay, so this is what is very, very important concept. So you see here, amount, that is the moles. If you multiply the number of moles into 6.022 into 10 to the power of 23, that is Avogadro's number, then you will get the total number of molecules present in that, or formula units. Formula units means what? Nothing but the molecules of the ionic compound. We call it as formula units. Okay. For ionic compounds, we have to call it as formula units. Okay. When the number of moles is multiplied with the molar mass, we will get the mass of that substance. So this is the relation shown here. Hope you have understood it. Yeah. Next, let us see another important thing, that is limiting reagent. Okay. Just now I said you that why are we studying these stoichiometric reactions? In order to get the maximum amount of product, right? Yes or no? In order to get the maximum amount of product, we have to study these stoichiometric relations. Otherwise, what happens? Without knowing the stoichiometry of the reaction, if you carry out the reaction, there is a chance that the reactants will go waste. Yes or no? The reactants will go waste. Let us understand with a very simple example what we are doing in our daily life. We are eating the food. Yes or no? Yes, we are eating the food to survive. Now, what happens is you are having large amount of rice, but the curry is very little. So how much will you eat? It depends upon the amount of curry. Yes or no? If large amount of rice is there, but curry is little, so the amount of food what we take in it depends upon the amount of curry. Okay. Now let us see the other case. Curry is more, but rice is less. How much will you eat? Again, it depends upon the rice only. So in the same way, whenever we are carrying out a reaction containing 2 or more reactants, okay? So we should see that these 2 reactants are supplied in an appropriate amounts. Okay, according as per the stoichiometry, they have to be supplied. If you are adding one reactant in the large quantity and the other reactant in the lesser quantity, what happens? The formation of the product depends upon the lesser quantity. So the substance taken in lesser quantity is only what is called as limiting reagent. So the formation of the product depends upon the limiting reagent. So how to calculate the limiting reagent? So in order to find out or how to know which substance is the limiting reagent means, first we have to go through the stoichiometry of the reaction. Okay, suppose A and B are reacting. So how many moles of A is required? How many moles of B is required? Okay, that you have to see. So are we carrying out the reaction as per the stoichiometry or not? We have to see. Then only we have to go for the reaction so as to get maximum yield of the product, so as to get more amount of product. So without knowing that, simply if we carry, the reaction will go waste, the reactants will be wasted. Again, we have to separate that all. That is a very tedious process. So before itself we have to go it in a proper way so as to get the good results. Okay, so let us see what is the limiting reagent. The limiting reagent or limiting reactant or limiting agent in a chemical reaction is a reactant that is totally consumed when the chemical reaction is completed. Okay, so that means what? Whenever the chemical reaction is taking place, the limiting reagent will be totally finished off. Okay, the amount of product formed is limited by this reagent. Okay, since the reaction cannot continue without it. Okay, if the reactant is finished, what happens? The product formation also will stop. So this is what is limiting reagent. Yeah, let us see a problem based on limiting reagent. Yeah, see the question. Dinitrogen and dihydrogen react with each other to produce ammonia as follows. Okay, so what it is? Dinitrogen means N2, dihydrogen is H2. So N2 and H2 are reacting to form NH3. This is ammonia. Okay, so what is given? Let us see. Calculate the mass of ammonia produced if 2 into 10 to the power of 3 grams of dinitrogen reacts with 1 into 10 to the power of 3 grams of dihydrogen. Okay, in the first bit they are asking us to find the mass of ammonia produced. Okay, and see, will any of the two reactants remain unreacted? Okay, so whenever a reactant is remaining in the reaction, okay, that reactant is called as excessive reagent, and the reactant whichever is completed during the reaction, that is called as limiting reagent. Okay, so here the question is asked that will any of the two reactants remain unreacted? Okay, if yes, which one and what would be its mass? So what is our first step? What we have to do? We have to balance the equation. So what is the equation? N2 plus H2 gives 2NH3. So you see here 2 nitrogens, here 2 nitrogens. On the left hand side we are having 2 hydrogens, but on the right hand side we are having 2 into 3, 6 hydrogens. So hydrogens are not balanced. So first we have to balance the hydrogens. Okay, so in order to get 6 hydrogens, what we have to do? We have to put 3 as the coefficient of H2. So it becomes 6 hydrogens. So now this is the balanced equation. N2 plus 3H2 gives 2NH3. This is the balanced equation. Okay, Now, you see in the question what is given. They are providing us with the weights. Yes or no? They are giving the weight of nitrogen and weight of hydrogen, and we are supposed to find out the weight of ammonia. So all these are given in the weights. So we are writing the weights of this. So N2 means what? Its molecular weight is 28. So 3H2. The molecular weight of H2 is 2 grams. So 3 moles, right? So 3 into 2. It is 6 grams. And 2 ammonia. Each ammonia, its weight is 17. So 2 into 17. So we are getting it as 34 grams. So this is according to the stoichiometry of the reaction. Okay. 28 grams of nitrogen should react with 6 grams of hydrogen to produce 34 grams of ammonia. Okay. This we have written. So you see here, 28 grams of nitrogen needs 6 grams of hydrogen. So 2 into 10 to the power of 20, 10 into 2, sorry, 2 into 10 to the power of 3, that is 10 cube. 2 into 10 cube grams of nitrogen is given. Okay, how much hydrogen is required, we have to find out. Okay. So you see, 2 into 10 to the power of 3 grams of nitrogen needs how much hydrogen? Let us see. So upon cross multiplication, you are getting it as 0.42 into 10 to the power of 3 grams of hydrogen is needed. This much is needed. But how much are we provided with? We are provided with 1 into 10 to the power of 3 grams of hydrogen. Okay. We are provided with 1 into 10 to the power of 3. But how much is required? 0.42 is required. 0.42 into 10 to the power of 3 is required. So here hydrogen is the excessive reagent. Okay, because it is provided more than the required quantity. So you see, but the amount of hydrogen provided is more than the need. Hence, hydrogen is the excessive reagent and nitrogen is the limiting reagent. So we have come to know which is excessive and which is limiting reagent. And we know that the formation of the product depends upon the limiting reagent. So see here. So the production of ammonia depends upon the amount of nitrogen as it is the limiting reagent. Okay. So we are supposed to find out how much amount of ammonia is formed, that we have to find out. So you see 28 grams of, now because nitrogen is the limiting reagent, so production of ammonia depends upon nitrogen. So you see 28 grams, this is from the stoichiometry. 28 grams of nitrogen produces 34 grams of ammonia. 2 into 10 to the power of 3 grams is provided, right? That produces how much? Okay. So again same, cross multiplication only. 28 grams needs produces 34. 2 into 10 to the power of 3 produces how much? So upon calculation, we'll get it as 2.42 into 10 to the power of 3 grams. So this is the amount of ammonia produced. Okay. In the second bit, the question was asked, will any of the reactant remains? Yes, hydrogen remains. Okay. So how much amount of hydrogen remains, we have to see. So just now we have calculated how much amount of hydrogen was needed there. 0.42 was needed. 0.42 into 10 to the power of 3 was needed. But we are provided with 1 into 10 to the power of 3 grams. So if you subtract that, you see here, hydrogen is the excessive reagent. Hence, it will be left behind. Okay, let us see how much is left. We know that 6 grams produces 34 grams. How many grams will produce? 2.42 into 10 to the power of 3 grams of ammonia. So this much hydrogen is needed. Okay. So how much would be left? 1 from 1 into 10 to the power of 3. If you subtract 0.427, you will get it as 0.57 into 10 to the power of 3 grams. So this much amount of hydrogen is left. Hope you have understood. Please Go through this, understand it. It is very simple. First, how to calculate the limiting reagent is write down the balanced equation. Okay. Then see how much of the two reactants are needed as per the stoichiometry. Okay. After writing the balanced equation, we will come to know how much of two reactants are required. Okay. Then you see how much is provided. If we are having the amount less than the requirement, okay, then that substance becomes the limiting reagent. In this case, nitrogen is the limiting reagent. Okay. And the substance which is provided in the larger quantity than the requirement, that is the excessive reagent. So whenever there is a limiting reagent, the product formation depends upon the limiting reagent. Yeah. Next, let us see percentage yield. So first we need to know what is yield. You might have heard, no, agricultural yield, we got the yield. Yield means the product. Finally, whatever we get, that is called as the yield, the product. Okay. Whenever we are carrying out a reaction, we get the product. How much amount of product we get and how much we have to get as per the stoichiometry. We have to see that. Okay. Actually, whenever we are carrying out a reaction in reality, okay, we can get the product lesser than the expected from the theoretical wise, or we can get equal to the product, equal to the amount what is based upon the stoichiometry. Hope you have understood. We can get the product, whatever we are getting the reality in reality, it could be equal as per the stoichiometry of the reaction, or it can be less, but it will never be more, because we will never get more than what we have provided with. Yes or no? So there is a chance that we would be getting the lesser amount of product, or we can get equal amount of product depending upon the stoichiometry. Okay. Suppose after carrying out the reaction, we are getting the lesser amount of product than the expected from stoichiometry of the reaction. So we can say that the yield is less. Okay. So why should we see this yield? So once ever we carry out a reaction, okay, if the efficiency is not good, that means product formation is not more, then we should not carry out that reaction, because it is waste of the reactants. There is a wastage of reactants occurring there. The reaction is not occurring in a proper way. Okay. So we have to go for an alternative method. Okay. So percentage yield will help us to know the efficiency of the reaction. Okay. This is an important thing. What is the use of percentage yield? To know the efficiency of the reaction. Let us see. Percent yield. Percent yield is equal to actual yield. That means how much ever we are getting the product actually by theoretical yield. Theoretical yield means from the stoichiometry. We are doing some calculation now. So theoretical yield into 100. That gives us the percent yield. Actual yield is the amount of product obtained from lab data. Okay. That's what I said no. Actually, how much ever we are getting from the lab, that is the actual yield. Theoretical yield is the amount of product obtained from the stoichiometry. Okay. Theoretical is the obtained from the stoichiometry. Percentage yield helps us to know the efficiency of the reaction. Okay. One example I'll give you. Let us go with a simple one. Okay. You have to get suppose in a reaction you have to get 60 grams of the product. Okay. But actually you are getting only 50. Okay. Why only we are getting 50 means there are so many reasons. The temperature might not be there. The reaction might need a catalyst. The pressures are not maintained. If it is the gaseous reaction, we have to maintain the pressures. We have to maintain the temperatures. Some reactions will need a catalyst. All these factors will be there in the reaction. Okay, if all these factors are provided enough, then only the reaction would be going to a maximum extent. When the reaction is occurring to a maximum extent, we'll get the product. Okay, so suppose if we are getting only, actually we have to get 60 grams of the product depending upon stoichiometry, but in reality how much are we getting? 50 grams only. Okay, so what is the theoretical yield here? 50 divided by 60 into 100. That gives us the theoretical, that gives us the, sorry, percentage yield or percent yield. Okay, percent yield helps us to know the efficiency of the reaction.
Can you close the session?
Yeah. Next, let us see redox reactions. Already I have told you number of times. Redox reactions are those in which both reduction as well as oxidation occurs. Okay. So you see here, one example is given. Redox is short for oxidation reduction reaction. Plating and combustion are redox reactions. So what is plating? Electroplating. You might have seen, no? On the silver articles, they will be depositing gold. Yes or no? Or on the steel, we'll be depositing some copper. Such types of reactions are called as electroplating reactions. Okay. Plating and combustion reactions are redox reactions. Okay, see this example. Iron is reacting with nickel nitrate and forming iron nitrate and nickel. So what is happening from here? Iron, there is a change in the oxidation state of iron. Here it is 0 and here it is Fe plus 2. It is becoming plus 2. How to know the charge? Crisscross valency. You remember, the valency of iron is written for the nitrate. The valency of nitrate is written for the iron. That we will be doing it in the crisscross valency method. Okay, so iron is changing from Fe to Fe plus 2. So what is happening? There is an increase. 0 is becoming plus 2. Nothing is there means it is 0. Oxidation state is 0. 0 is becoming plus 2. So that is oxidation. And observe here, nickel. Nickel is changing plus 2 to 0. This is reduction. So we will further go through this in the next class. So you please go through the textbook, solve the problems, okay? And learn the concepts. It is very, very important chapter. Number of problems are asked for the competitive exams. So please, once again, rewind the class and see and go through the textbook, solve the problems. With this, I conclude. Let us see the remaining part in the coming days.